Hi student, greeting all. Today I am teaching you the Newton's second law of motion. Now in the last video of mine, you must have seen the statement of the Newton's second law of motion. Today exactly I am giving you why Newton's second law of motion is the fundamental law of motion, and also we will come to know about impulse from the Newton's second law of motion. You must have known the statement of the Newton's second law of motion. Once again I am repeating the statement with you. So what is the statement of Newton's second law of motion? It states that the rate of change in momentum of a body is directly proportional to the force applied, and the change in momentum takes place in the direction of the applied force. So from here we will come to know that the mathematical expression of the Newton's second law of motion is delta P upon delta T is equals to F. This is one of the mathematical expression, and also we have known that we have derived F is equals to ma. Here this is true when the mass of the body is constant. This equation of the Newton's second law of motion is correct only when the mass of the body is constant. But this equation of the Newton's second law of motion is true all the time. So here what we will get? M as constant. So now today I am teaching you this Newton's second law of motion is the fundamental law of motion. Now why should we say Newton's second law of motion as a fundamental law of motion? What is the reason behind that? See students, from the Newton's second law of motion we can derive the first law and also the third law of motion. Therefore Newton's second law of motion is the fundamental law of motion, or this is the real law of motion. So now see how to derive Newton's first law of motion from the second law of motion. See here we will derive Newton's first law of motion from the second law. So according to the Newton's second law of motion, we know F is equals to ma. This is the expression of the Newton's second law of motion that I have told you. F is equals to m into a. Now if F is equals to 0, what is the meaning of F is 0? Means no force is acting on our body. No force is applied on our body. Now when no force is applied on the body, if in this equation F is equals to 0, then we can write here that implies m into a is also equals to 0. Now m a is equals to 0. So here that implies a is equals to what? 0. Why? Because m cannot be 0. M is the mass of the body. So m is not equal to 0. So therefore now we are considering a is equal to 0. A stands for what? Acceleration. Thus the acceleration is equals to 0. Now what is the meaning of acceleration of a body is 0? When the acceleration of the body becomes 0, we know that acceleration is the rate of change of velocity of our body, or when the body is moving with changed velocity, then the acceleration is produced. So here a body is moving with 0 acceleration. It means that the velocity of the body is constant. That means when a body is moving with a certain velocity, this velocity of the body does not change. A body moves with the constant velocity, then the acceleration of the body becomes 0. Or if a body is in the state of rest, then there will be no acceleration. if the body remains in the rest or if there is no motion at all, body is not moving at all. So what will be the acceleration of the body? The acceleration of the body will become 0. Suppose say for example, now if a body is moving with a velocity of 5 meter per second, suppose this is a body moving with a velocity of v1 is equals to 5 meter per second. Now after say 10 second, if the velocity of the body remains the same, that is 5 meter per second. See, initially the body was moving with the velocity of 5 meter per second. Now after 10 seconds, the body is moving with the same velocity. Is there any change of the velocity? There is no change of the velocity. The body is moving with the constant velocity. So during this time, the acceleration of the body becomes what? 0. That means when a body moves with a constant speed or constant velocity, then the acceleration of the body becomes 0. And other case I have told you, if the body is at rest, suppose this is a body and there is no motion of the body, that means the velocity of the body is 0. Now after say 10 seconds, again we are seeing the velocity of the body becomes 0. That means the body is at rest, which shows that there is no motion of the body. So what is this? What is this I have explained you? This is the Newton's first law of motion. What is Newton's first law of motion? What it says? It says that if a body is at rest, it will remain in the same state of rest, and if the body is in the motion, it keep moving with the same velocity in the same direction, which means that the acceleration of the body is 0. So which is the statement for the first law. So therefore, in this way we can derive the first law from the second law of motion. So now I will discuss about the examples of the Newton's second law of motion. From the Newton's second law of motion, you know that we know delta P by delta T is equals to F. That implies delta P is equals to F into delta T. Isn't it? This is known as your what? Change in the momentum. And this is the product of force and the duration of time for which the force is applied on our body. Isn't it? From this expression you are knowing this. And this is known as impulse. So what is impulse? Therefore, change in momentum is known as impulse. So now we can write here impulse is equals to F into delta T. That means impulse is also defined as the product of force and the duration of time for which the force acts on a body, or the change in momentum of a body is known as the impulse. Now see over there, this change in momentum, that is delta P, for a given change in momentum, if the magnitude of the force becomes more, then what happens to this time? Time becomes less. And if the duration of time is more, then what happens to the magnitude of force? Magnitude of force becomes less. See this expression. Since we know delta P is equals to F into delta T. So for a given change in momentum, if the change in momentum is constant, for a given change in momentum, if the force is more or if a larger amount of force is applied on a body, then the duration of time has to be small. Or if the amount of force will be less, then the duration of time will be more. So then only we get the change in momentum as constant. So there are some of the examples of this you will be getting. What are these? Just I am discussing with you. Whenever a cricketer catch a ball, he has to withdraw his hand in the backward direction, isn't it? If suppose one ball is coming, the cricketer has to catch the ball, then after catching the ball, the cricketer has to pull the hand in the backward direction. So what is the reason behind that? By doing so, cricketer is giving some time to bring the ball into the state of rest. So when some time is given, at that moment what happened? The force exerted, you have known that change in momentum is equals to F into delta t. Here change in momentum means what? The final momentum will be becoming 0 because the ball has to come into the state of rest. Initially it was moving. So for the given change in momentum, if the duration for the time will be longer, then what happened to the force? The force applied will be less. So while pulling the hand in the backward direction, what happened? The duration of the time for which the ball comes to rest is increased, and in the same time the force applied by the ball onto the hand of the cricketer becomes less. Therefore, the hand of the cricketer will not be injured. So due to this, a cricketer has to withdraw his hand while catching the ball. So this is one of the example I have given. Some other examples are also there. So whenever you are jumping on a carpeted floor, you will get less hurt compared to that of a cemented floor. In the same way, whenever a glass falls on a carpeted floor, it does not break. But when the glass falls on a cemented floor, it breaks. What is the reason? Same reason will be there. Now in the case of the cemented floor, what happened? As soon as the glass drop on the floor, at the same moment it comes into the state of rest. That means the time for which the body comes into the rest is very, very less. So for the given change in the momentum, if time is less, then what happened to the force? A large force is exerted by the glass on the floor. And at the same time, force of reaction also exerted by the floor onto the glass, and the force of reaction will be same amount to that of the force of action. Therefore, the glass breaks. Now, if the same glass is falling on a carpeted floor, what happened? The duration for time for which the glass comes into the state of rest will be more. And due to that reason, the applied force by the glass onto the floor will be less. Therefore, the force of reaction by the floor onto the glass will be less. Due to this reason, the glass does not break. So these are the examples of the Newton's second law of motion. Thank you.